Hello, welcome to the National Institutes of Health. My name is Brandon Hartz, and I'm the NIH landscape architect. I've been in my position for 5 years now, and I'm proud to have you along with me for a virtual Walk the NIH stream tour. So welcome. We're just a couple hundred feet away from where we last were. I brought you here to take a look at this majestic tree behind me. This is an American beech tree. There is a relative beech from Europe. This one here is native to the mid-Atlantic. This happens to be a very large specimen. One of the most defining features of the American beech tree is the extremely smooth bark, as you can see in the background. It looks almost as though it has elephant skin. Unfortunately, because of how smooth the bark is, this tree is very susceptible to vandalism. If you see this tree growing in your parks near you, you may see that people have carved initials or other messages into the tree, kind of like graffiti. And this does a lot of damage to the tree, so this should be avoided at all costs. One thing I did want to point out was that each of our trees on campus has a metal tag which helps to identify it. The tag on this tree is right here. And this is tree number 7631. So if I was interested in learning more about this tree, there is a database of trees in electronic format where you can type in the tree number and get all sorts of information about the tree. You can find out the species of the tree, you can find out the height of the tree, the width of the canopy, the size of the trunk, when it was planted, if it's known, and where on campus it's located. It is a great resource for NIH. Welcome to the banks of the NIH stream. This stream runs along the eastern property edge of the NIH property here in Bethesda. We've got 210 acres of our 310 acres are in the watershed which drains to this very stream. For the kids that are watching, that's equivalent to 600 elementary school soccer fields. It's quite a big area we're talking about. This stream feeds into other waterways in the Washington, D.C. region and eventually runs into the Chesapeake Bay watershed, which is a very sensitive estuary ecosystem. In 2003, the NIH restored over 2,000 feet of this stream, a lot of what you see here. The length of stream that was restored is equivalent to the length of 65 school buses put back to back to back. In the summertime, we get a lot of water rushing through this stream. The average quantity of water that we'll see is 550,000 gallons of water on a daily basis, which is equal to one entire Olympic-sized swimming pool. There's a lot of water that comes through these very banks. Now in winter, we don't have nearly as much water as we have in the summer. We only have about 100,000 gallons in the winter. The stream covers about 90% of the campus drainage. Now our campus has quite a bit of topographic change, and our water, or rainwater when it falls, does drain in different directions, but the vast majority of the rain that falls on our land here in Bethesda does end up in this stream, which eventually connects into Rock Creek Park. Welcome to the start of the NIH stream. This is where the underground pipes that collect under NIH with stormwater from all over are daylighted to the start of our stream on the east side of campus. It's hard to see back in the distance, but behind some of the green foliage, is about a 6-foot diameter pipe, which allows stormwater in storms to rush through into the start of our stream. What can also be seen in the background, just behind me here, is a large, what we call catchment basin. And the purpose of this basin is to allow the water that's coming out of our pipes to go into the basin and allow any trash like bottles, cans, paper to make it to the surface so that we can collect those items before they head downstream and off of the NIH property. It also allows any dirts or silts that have made their way into the stormwater, especially if we've had a big storm and water is rushing off the ground. It tends to pick up small particles. So one thing that the catch basin is really good at is slowing water down, keeping it from moving, allowing it to pool up, and then any of those dirts or silts can settle to the bottom. And at some time in the future, we can come through and scoop those sediments out. So you may be asking, what happens in a very, very big storm? Well, this system doesn't function the very same way. So this catch basin has only been designed for storms up to a certain size. So with very, very big storms, what happens is water will, what we call, bypass that system and rush into our stream corridor. What you may see over the course of this video is there's lots of rocks that make up the banks of the NIH stream. And this was very much done on purpose during the engineering of the stream restoration. So the rocks help to stabilize the banks of the stream so that we can minimize the amount of erosion that happens as water is rushing through those corridors. They also allow opportunities for water to spill over and down and for water to crash into rocks and help to further slow down the movement of water, because slower moving water has less erosive effects. When the NIH stream was restored back in 2003, 730 trees and over 5,000 native grass plugs were planted in this very corridor you're looking at. Over 5 acres of land was set aside as what we call no-mow landscape buffers. So what you're seeing here is the growth of a landscape ecosystem that we don't actively go in and maintain by mowing. And this is very important for the health of the stream. One thing that a full landscape buffer helps to do is to filter out things like the sediments that we talked about with the outfall, pollutants coming from the roadway when people's oil and gas spills onto the road, winter snowmelt chemical, the roots and the plants that are make up these banks help to make sure that the water, as it passes through those areas, is filtered out before it makes it to our stream, making our stream a much healthier ecosystem. There are 31 different species of trees that are currently growing within our NIH stream corridor. The tree canopy that is above us serves a very important function. It shades the water, and fallen branches from the trees into the stream area becomes habitat for aquatic life. The trees also produce seeds, nuts, fruits, and those types of things are eaten by the birds and the mammals that inhabit this area. The interesting thing about most of the trees that you'll find within the NIH stream corridor is that they're very resilient types of plants. And that goes for not just the trees, but also the shrubs and the herbaceous plants and the forbs. And this is because there are times, if we don't have rain for a few weeks or even up to a month, where the soil tends to get very dry, even in a stream corridor. But there are also times, like the springtime that we're having, where we get a lot of rains and a lot of water is making its way to this corridor. So that means the types of plants that live in this ecosystem need to be able to withstand both very dry conditions and sometimes very wet conditions. And there's very limited number of plants that can withstand and thrive within those types of soil conditions. One of the trees that I'd like to point out to you that you'd see a lot in this NIH stream corridor, but you might also see a lot in your neighborhoods, is this tree right here. And this is called an eastern redbud. It's a small ornamental flowering tree which is native to the mid-Atlantic United States. Right now you can see it's in full bloom, and it blooms for a fairly short time, about a week and a half to 2 weeks. It's got a nice purple flower. And the most interesting thing about the redbud is that most flowering trees will only bloom off of the current year's growth. So any new growth that's happened in the year that you're in will produce blooms. The interesting thing about an eastern redbud, like I said, which is not like most trees, is that it will actually bloom off of old wood, meaning you could see blooms coming out of the middle of the trunk. And in fact, we'll try to pull an image of one from another tree to show you just that. Another tree I'd like to bring your attention to is right behind me here. This tree is called a river birch, and this is another tree which tends to thrive in both dry and wet conditions. The most defining feature of this tree, which can be seen, is that it has this nice peeling bark. And it's this bark which makes it an extremely interesting tree for any of your landscapes. You'll see these in plazas, parks, and other street sides such as this. I'm standing next to another common tree in the stream corridor. This is a young sycamore tree, which will grow up to be very large and loves the same type of wet and dry conditions. Another thing I'd like to point out for your attention is these dangling branches. These were once a living vine that grew from the banks of the stream and up into the tree, basically trying to attack the tree to kill it. These vines were cut down last fall in 2020. They are part of what's called the porcelain berry vine. The porcelain berry vine is a very vigorous vine grower which tends to proliferate in stream corridors like this. It grows from the banks of the stream up into our tree canopies and tries to starve the tree's leaves of light. It will also draw nutrients out of the soil and compete with trees and other low-lying plants. We have to come through these corridors, not to mow, but we do have to be careful for plants like this and make sure we do spend some attention on making sure that Maryland invasive plants keep from taking over our natural areas. Now made our way around 3/4 of the way through the NIH stream tour, but I did want to stop here next to this old, dead, decaying tree that is left in place, surprisingly to some of you. This tree we call a snag, and a snag is basically a tree that has died or is close to dying, and instead of completely chopping it to the ground, what we do is we saw off the top of the tree, we cut off all the branches, and we actually allow the tree to remain in place. And what happens is over time, the weather, the rain, animals will begin the decaying process for the tree. And some of the first steps that will happen is the bark will fall off, insects will move into the tree to help with the decaying process, and then animals will come to feed on the insects, things like woodpeckers and small mammals. And as you can see here, this is a habitat point. This is a point of entry for a small mammal or a bird to make its way into this tree and use this tree as a home. So although this tree is no longer living, it now has a purposeful second life as a home for some of the native animals in the area. So what is the importance of snags? Snags are kept so that they reduce our costs for maintenance. We can spend less on cutting trees down, but they also do double duty of allowing us to create and maintain habitat on the campus. Eventually, this tree may become so unstable that we actually have to take it down, or parts of it may end up falling, and we just make sure we don't leave dead trees like this near areas where if they fell, they could cause damage. So this one here is far enough into the stream corridor that if it were to fall in any direction, it wouldn't actually do any damage to anything. And then of course, any of the bark or branches that do fall off and make it to the ground, as they decay over time, they're going to then be bringing nutrients back into the soil for plants in the future to use as nutrients to grow up and become a new forest stand in this area. I'm here next to one of our bluebird boxes on campus. We have over 100 eastern bluebird boxes spread out amongst the 310 acres of the NIH Bethesda campus. I lead a group of about 24 volunteers who walk along these trails and help to monitor the types of birds that are coming into these nests, into these nest boxes and creating nests and their own families of baby birds. So I'm going to teach you guys how to go about monitoring a bird box so that if you get one for your own yard, you'll know the process. So the first thing to know is that the bird makes its way in and out through this small hole in the front of the box. Now that hole is small on for a very specific purpose. You want to be able to keep large birds and other animals from getting into the box. You don't want a raccoon being able to get into the box to get to the birds. That would be very bad for the baby birds. It also keeps invasive birds out of the boxes. Things like European starlings, which will need a much larger hole to fit through. So the types of birds that we typically see in these types of boxes that we have on campus are the types of birds that would naturally nest in the snags that I was showing it a little bit earlier. They need cavities and things. So this box is a man-made version of a hole in a tree. The types of birds that like that are desirable, the eastern bluebird is one that we try to attract. The house wren is another one that happens to like areas which are a little bit more wooded since they use tree twigs for their nests. We also see tree swallows in these boxes, which makes their nests primarily out of grass and straw, and sometimes some of their feathers. If we see chickadees in these boxes, it's quite rare, but we do get some chickadees in these boxes. We do have to be on the lookout for house sparrows. Now, if you don't know what a house sparrow is, I'm sure you've seen one. If you have food outside in your yard or at a park, they're the ones coming to beg for your food. And they are also invasive and they will take over these boxes. So one of the reasons we have to monitor these boxes is to make sure house sparrows are not coming into them. So the way that we approach a box is we knock or we make some noise so that we let the birds know that we're coming. These nest boxes have a way of us being able to peek into them to see what is going on, and we would see whether there's the start of a nest, and if so, whether it was a type of bird that we want to nest in this box, or something like the house sparrow, which we want to kick out. And we take notes on all that, collect data, and I have historical records of all the bird data going back at least 15 years here at the NIH. So that's our bluebird boxes. I'm here along Wilson Drive, which crosses over part of the NIH stream. And I'm here to point out the edge of Wilson Drive. What do you don't see here? You don't see a curb along the edge of this road. And that is very purposeful. It is actually engineered that way, so that any stormwater that falls on this road, the water will run off and come directly into the landscape, make its way through the landscape buffer that we talked about earlier, and be cleansed by the landscape plants in the soil before making its way onto the stream. So any types of winter snow melts, or gasolines, or oils will be filtered out before they make it into our stream. Right, we're near the end of our tour here, but I did want to take you inside the forest edge a little bit to show some of the new trees that are emerging out of the ground and what this future forest may look like in this area. I'm standing here next to an eastern red cedar, which is a type of juniper that's native to the Mid-Atlantic region. And you can see behind me there's a bunch of new eastern red cedar growing up out of the ground. And one of the reasons why this tree is one of the only ones that is coming out of the ground to form a new generation of trees is that we have a very large deer population on our NIH campus, and a lot of the deer happen to live within our NIH stream corridor. The deer love to nibble on new emerging trees. Any of the hardwood species that you would typically see growing up in a natural area like this, things like tulip poplars and maples and oaks, all those types of trees are killed by the deer before they can make it large enough to be this size. The only reason why this tree and others like it are able to grow is because these are very much a deer-tolerant species, and in fact, juniper in general is a very deer-tolerant species, which is why in our landscape plantings all around campus there is a proliferation of juniper used, as the deer will not touch it. Thank you for joining along for our virtual NIH Walk the Stream tour. I hope to see you all in a future in-person campus tour. Goodbye.